Okay, in this video lesson, we're going to be looking at solving literal equations. This is kind of a challenging lesson because we're not like solving to determine an actual value or number. We're solving for different variables. So let's just take a look at this example one. This is an equation that's actually how we solve for the area of a rectangle. The area is equal to base times height, or maybe you remember it as length times width, okay? Well, anytime you have an equation that's solved for a certain variable and there are other variables, you can always solve for one of the other variables. So that's what today's lesson is about. You're going to take this equation, capital A equals BH, and instead solve for H. Well, in order to do that, we're going to solve it like any other equation. We're going to use opposite operations or inverse operations, which is the same as saying opposite. So in this example, we are asked to solve for H. Well, here is our variable H, and on the right side of the equation, it's being multiplied times B. H times B or B times H. Well, if we want to solve for H, we use the inverse or the opposite of multiplying times B, and we divide by B. But remember, equation, you have two sides, the left and the right, and whatever you do to the right side, you must do the exact same step to the left side. So we're going to divide this capital A by the B as well. Now, on the right side of the equation, the B divided by B is just 1. And of course, 1 times H is just H. So all we're left with on the right side is the H. And we have the equal sign in the middle. And over here on the left side, we have capital A divided by B. And we don't know what any of these values are, but we now know that you can determine H, or the height, by dividing the area by the base. So our answer is A divided by B. H is equal to capital A, or the area, divided by the base. You may also see it written with the H on the left side. It doesn't matter. H equals capital A divided by B. So that is solving a literal equation. That's a single step literal equation.